Okay, for topic 4, we're going to look at something called break-even problems. Now, I've always called this type of problem break-even problems. I'm not entirely sure if your official textbook calls them this or not. I cannot remember off the top of my head. But basically, a break-even problem models a situation where two quantities or two processes become equal at some point, and our goal is to find the point where this happens. Okay? Now, frequently you will see these in like finance type problems where you're dealing with revenue, cost, and profit. Okay. So a lot of times you like companies, for example, they're doing some kind of, financial planning, some kind of financial model. They need to know where revenue, the money they're bringing in, is equal to their cost. That would be the break even point for whatever they're selling. So they're selling widgets or whatever. A lot, that's something we use in math. It just means this little like doohickey that you're selling. Okay, so you're selling some item, you have to figure out how many units you would have to sell for your revenue to be exactly equal to your cost. That's when you break even. You're not making any money, you're also not losing any money. So if you can sell more units than whatever the break even point is, then you'd make a profit. If you sell fewer units than the break even point, you're losing money. Okay, so that's kind of how these problems work. But the cool thing is it can apply to situations that are not necessarily related to finances, like with revenue and cost, okay? Typically, they do involve money, but not always, okay? Now, steps to solve the break-even problems. This is another just kind of consistent type of problem where if you have a situation like this, you can set it up in like a similar format. So each problem is going to be slightly different. There's no like tried and true way to solve any type of word problems, but these are similar enough that you can follow the same general process, okay? And that process is to assign a variable to the unknown value. So if we go back to this idea of revenue and cost, okay, let's say again, you own some company, you sell widgets, okay? So you own a company and you produce and sell widgets. Well, the unknown value would be the number of widgets you would have to sell for your revenues to equal your cost. Okay. So the unknown value would be the number of things that you're selling in this case. Okay. So we first have to assign the variable to the unknown value. For us, it could be a little bit, it may not be like a specific thing that you're selling, but for example, we're going to look at renting a moving truck, and the thing that is unknown is the number of miles. Okay, so how many miles would we have to drive for company A to be the same price as company B? So that would be the break-even point. Okay, so assign your variable. And then you want to create two expressions using this variable to model the two situations. So again, in just a bit, we're going to look at moving trucks. So one expression for the first moving truck, another expression for the second moving truck. Okay. And then you set those two expressions equal and you solve. And that's exactly what would happen in a revenue and cost situation. You would find an expression that represents your revenue, another expression that represents your cost, and then you'd set them equal. Okay. So even though a lot of these problems revolve around revenue and cost, not always. They can have other situations going on too. So let's look at our examples here. All right, so example 5 says solve each problem, include correct units with the final answers. Okay, now remember, I've said this in the other videos. I'm your algebra teacher. This class is not titled Trial and Error. Okay, we're in quantitative literacy. We want you to be literate with quantitative themes, okay? One of those is algebra, so we want you to understand the basics of algebra. You can do some trial and error and you can figure these answers out, but I am interested in the process, not just the final answer. I want to see an equation and an answer, okay? So, part A, it says you need to rent a moving truck. Okay, you identified two companies that rent trucks. ABC Rental charges $30 a day. That's just the flat fee, whether you drive 1 mile or 1,000 miles. They're going to charge you $30, and then they're going to charge you an additional 15 cents per mile. So let's kind of outline the ABC rental in yellow. So ABC rental, $30 per day, 15 cents per mile. Okay. We then have You Do It Rental. I don't know where these names came from. You Do It Rental charges $15 a day. So they charge you less per day, but they charge you more per mile. So they charge you $15 a day, but then they charge you 30 cents for every mile that you drive. So you drive 1 mile, 1,000 miles, you're getting charged that $15. That's a flat fee, but every mile you drive, you get charged mileage for that. So the You Do It rental charges $15 a day, 30 cents per mile. Okay. So that's the two really, really, really important pieces of information here. Okay. So we have a general idea of what's going on. We have two rental companies. They both have a similar charge in the sense that they charge you a flat fee and then a cost per mile. So they have a similar like model for how they charge you. Okay. But the flat fee and the cost per mile, different. So what you need to figure out is how many miles could you drive for the daily cost to be the same? Okay, the break-even point would be how many miles, where ABC Rental charges the exact same amount as You Do It rental. Okay, so let's assign a variable. We want to let X equal the unknown. In this case, the unknown is how many miles would you have to drive. So let X equal the number of miles. Okay, now let's just come up kind of with basic expressions to represent the cost for ABC rental and then the You Do It rental. Okay, for ABC, they're going to charge you $30 a day, period. Okay, in addition to that $30, they're going to charge you 15 cents for every mile that you drive. So 15 cents, we want to write it as just 0.15, and then we want to multiply it by X. Okay, so I'm going to outline this one in yellow just to make sure we're keeping our information together. Okay, now for You Do It, they only charge you $15 a day, but they have a steeper cost per mile. They charge you 30 cents per mile, so we're going to go 0.3 or 0.30 times X. Okay, and that is going to be outlined in pink. Okay, now the directions told us once you assign a variable and then create an expression for each situation, you set those expressions equal to each other, and that becomes the equation that you solve. So we want to take 30 plus 0.15x and set it equal to 15 plus 0.3x. And now, y'all, we have an equation that we can easily solve. Okay? Whoops. Well, that was kind of nice. It made a perfect arrow. All right. So I like to always address my variables first. In this case, we don't have any parentheses that we need to get rid of. We don't even have to simplify on the left or the right. The left and right are as simple as they're going to get. They have a single variable term and a single constant term. What we need to do is we need to get all of the constants from both sides of the equation into a single term on one side of the equation, and then all of the constants in a single term on the other side. I generally will always address my variables first, and I typically move them to the left. So that means this plus 0.3x, I want to move it to the left. So how do we undo addition? We subtract. So I'm going to subtract 0.3x from both sides. All right. So on the left, that 30, we just drop it down. But then for 0.5x minus 0.3x, if you need to use a calculator to do that arithmetic, that is fine. I'm just going to write it as negative 0.15x. You can trust the process, or you can pause the video and get out a calculator and just double check, but it should be negative 0.15x. And then on the right, the 0.3x's cancel, okay, because 0.3 minus 0.3 is 0. And then 15 plus 0 is 15. Okay, so we've managed to successfully get all the variables in a single term on the left. Now we need to get all of the constants on the right. And currently my issue is this 30 on the left. Since it's positive, we can think of that as like plus 30. I want it to be moved to the right. So we move addition with subtraction. So 30 minus 30, 0. And then that leaves us with just negative 0.15x. And then on the right, 15 minus 30 is negative 15. Okay, so we've got a single variable term equaling a single constant term. We want to go ahead and undo the multiplication of negative 0.15 and x. So we undo that with division. On the left, negative 0.15 divided by negative 0.15. We say they cancel. Just remember, they cancel because they have a quotient of 1. 1 times X is X. And then if you need to, you can again use a calculator here, but negative 15 divided by negative 0.15 is 100. Well, 100 what? 100 miles. So 100 miles and the costs are the same. And that's it. So basically, we would use this to decide which rental company we need to use. Okay. So kind of consider it like this. If you're moving locally, so let's say you live in Asheville and you're moving 5 miles down the road to a new apartment, you're not going to be driving that many miles. You're just going to make a couple of trips from one apartment to the next. You're going to benefit from the lower cost per day. Even though the mileage cost is much higher, you would benefit here. So you would choose this company if you drive less than 100 miles. Okay. Now let's say you're doing a long haul move. You're moving from Asheville to San Antonio, Texas. You're going to be driving way more than 100 miles. You're going to benefit over here with the ABC rental. Even though the daily cost is higher because you're driving so many miles, you're going to benefit from the lower cost per mile. So this one, if you drive more than 100 miles. Now, I'm not asking you to necessarily analyze that, but that is why you use these break-even problems. They just kind of help you make those business type decisions where you're picking between, two companies like that. Okay. Now, they don't always have to involve money, but they typically will. Okay. So that is a break-even problem. All right. Part B. Let me scoot this picture out of my screen. Okay, part B, it says you are choosing between two plans at a discount warehouse. Think like Costco, Sam's, that kind of thing. Okay. Plan A has a $300 annual fee and you pay 70% of the retail price. So you buy this membership card. It's going to cost you $300 a year, but every time you buy products, you get a 70%, or you don't get a 70% discount. You pay 70% of the retail price, which means you get a 30% discount. Okay. Now, Plan B is different. Plan B has a $40 annual fee, so it has a much, much lower annual fee, but then you pay 90% of the retail price. So you still get a discount, but in this case, you're only getting like a 10% discount. So how many dollars of merchandise would you have to purchase to pay the same under each plan? So basically, in this case, what we're looking at is how much money you're spending at this discount warehouse, okay? For each dollar you spend, that's what's going to tell us kind of that break even point. So what we're going to do here is we're going to let X, sorry, I need a sip of water. All right, so what we're going to do here is we're going to let X equal the amount of merchandise you purchase. So we're going to say X is the dollar amount of merchandise. So how much merchandise would you have to buy for these two plans to end up being the same amount in the course of a year? Okay, so let's go ahead and highlight some stuff. So let's do yellow for Plan A. So Plan A charges you $300 a year, but then you only pay 70% of the retail price, which is like a 30% discount. And then Plan B has a 40% annual fee, but you pay 90% of the retail price, which means it's only a 10% discount. So how much money would you have to spend for these two to cost exactly the same? And that can then help you decide which one's going to be the better financial fit for you. Okay. So let's create some expressions. So for Plan A, the cost is going to be $300 a year, whether you spend $1 or $1 million. Sorry, I have a little tickle in my throat. So you're paying that $300 no matter what. But you also then only have to pay 70% of the dollar amount of the merchandise. So you're only paying 70% of the retail price of goods. That's going to be your X. Okay, so let's outline this one in yellow. Okay, now for Plan B, this one's a little different. This one seems to be geared more towards people who aren't going to be spending as much, and I'll explain why in a bit. But for Plan B, you pay $40 a year, okay? And then you pay 90% of the retail price. So we pay 90%, so 0.9 times X, which is going to be the dollar value of the merchandise you buy. So the dollar amount of the retail price. Okay. So X, and we get ink. All right, so let's kind of talk about this one more time. So for plan A, you're paying $300 regardless. Okay, for the year, you're going to pay $300. And then you pay 70% of the retail price. That's X. Okay. And then for plan B, you pay $40 a year. So you have a much lower annual fee, but then you don't get quite as good of a discount. You pay 90% of the retail price. That's the dollar amount of the merchandise that you're going to pay or buy throughout the year. Okay. So what we have to do for a break-even problem is then set these equal to each other. So 300 plus 0.7x equals 40 plus 0.9x. And now we solve. So this is going to be very similar to the previous one. We don't have to get rid of parentheses. We don't have to combine like terms on the left or the right, but we do need to get all of the variables in a single term on the left, all of the constants in a single term on the right. Okay. So I have this plus 0.9x. I want to move it to the left. So I'm going to subtract 0.9x. So on the left, I drop down my 300, and then 0.7x minus 0.9x is going to be negative 0.2x. And then on the right, I'm left with just 40. The 0.9x's become 0, so we would say they cancel. Okay? Now, I want to isolate my negative 0.2x, so that means I want to move that 300. Since 300 is positive, we think of it as plus 300, so I want to subtract 300. So 300 minus itself is just 0. We would say they cancel. So we get negative 0.2x equals negative 260. Okay, so 40 minus 300, negative 260. And finally, we have a single variable term equaling a single constant term. We need to undo the multiplication of negative 0.2 and x. So I would divide. All right, so negative 0.2 divided by itself is just 1. We would say they cancel. 1 times x is just x. And then, let's see, 260 negative 260 divided by negative 0.2, and I get $1,300. So that is the amount of merchandise you would have to purchase for the plans to be the same. So this is the amount of merchandise you would have to buy. Don't spell buy that way. Bless my heart. B-Y for the plans to cost the same. Okay, so that's how much you'd have to spend there in the course of a year on just merchandise for these two plans to cost the same overall. Okay, that would be your break-even point. So imagine you're a family of like 8. You, a partner, spouse, 6 kids. You're going to be buying a lot of fruit snacks, a lot of apples, a lot of Capri Sun, a lot of meat, a lot of cheese. You're going to be spending a lot of money on groceries. In the course of a year, if that's where your main shopping is done at, you're going to be spending way more than $1,300 a year. So for you, even though the flat fee is higher, you're going to benefit greatly from that bigger discount. Okay, so by only paying 70% of the retail price, this is like a 30% discount. So this would be what like the Duggars or that 19 kids and counting family or John and Kate plus 8, like these huge families, this is what they would want. They would want the bigger annual fee because they get a bigger discount. Now, say you're just a single person, you're going to get your prescriptions here, you're going to buy your toilet paper in bulk, you're going to buy your cans of Diet Coke, you're going to spend some money here and there, but it's not going to be that much per year. You're going to benefit much more from the lower annual fee. Even though you're paying a larger percentage of the retail price, if you're not spending $1,300 or more, you're actually going to benefit from the plan B. Okay, so there you have it. That is break-even problems. This one, even though it's only a 10% discount, this is better for those spending less than $1,300 a year. which by default means plan A is better for those spending more than $1,300 per year. So that is break even problems. That's kind of how you analyze them. You sort of figure out what that sweet spot is. That's the break even point. Some people are going to benefit from more than the break even point. Others are going to benefit from less than the break even point. So there you have it. One more video and we are done with another very long section. In the last video, it'll be pretty quick. We're going to solve formulas for a specific variable.